Hi scholars, let's prove the square root function is continuous. To start, let's recall the definition of continuity that we will use. We say a function f is continuous at a point z, provided for all epsilon greater than 0, there is some delta greater than 0, such that for all x in the domain D of the function, we have that the absolute value of x minus z less than or equal to delta implies that the absolute value of f of x minus f of z is less than or equal to epsilon. Further, we say the function is continuous if it is continuous at each point in its domain D. Whenever possible, I try to start my proofs by considering a diagram. So here's a plot of the square root function. We need continuity at each point z, and so I consider an arbitrary positive point z. The case for z equals 0 can be handled separately. Next, in our definition, we are given some positive epsilon as a bound on our function values. We can visualize this by drawing this shaded region between the square root of z minus epsilon and the square root of z plus epsilon. What we need to do is show there is a positive delta such that if x is within delta of z, then square root of x is within epsilon of the square root of z. Now, since the square root of x is non-negative, we can bound the difference between the square root of x and the square root of z as shown here. This corresponds to the white line shown of the square root of z plus x minus z over square root of z. The white circles tell us x values that we can use to identify delta. Specifically, we can include vertical dashed lines and label the horizontal distance between these and z as delta. Importantly, note if we pick x in the interval from z minus delta to z plus delta, then the square root of x will stay between the square root of z minus epsilon and the square root of z plus epsilon, just as we'd hoped for. Now, we can also explicitly solve for delta. At the top right corner of the box with green and red shading, the white curve has the value square root of z plus delta over square root of z, while the red dashed line is at the square root of z plus epsilon. This implies that delta equals epsilon times the square root of z. Alright, with that, we can now formalize this in our proof. Because we want to show the square root function is continuous, we will consider an arbitrary point z in its domain and show it is continuous at that point. Then, to use the definition of continuity shown, we will typically also let some positive epsilon be given. By our definition, it suffices to show there is some delta greater than 0, such that if x is non-negative and the absolute value of x minus z is less than or equal to delta, then the absolute value of square root of x minus square root of z will also be less than or equal to epsilon. We will find it easiest to tackle this problem by separately considering the cases when z is positive and when z equals 0. First, let's suppose z is positive. If you give me any non-negative x that is within epsilon times square root of z, then we have the following list of inequalities. First, we multiply the square root of x minus square root of z by its conjugate so that the numerator just becomes x minus z. The absolute value of the bottom is simply square root of x plus square root of z, since each of those terms is non-negative. Next, because x is non-negative, we can bound this expression by what you see next, where there is just square root of z in the denominator. Now, this is where our perhaps sneaky choice for a value of delta comes in. I know the numerator can be bounded by my choice for delta, and I want the entire fraction to be less than epsilon. So I pick a bound delta that can make this happen. This corresponds to what we saw in our diagram earlier. Specifically, in this case, that's delta equals epsilon times the square root of z. Sure enough, if we plug that in, then everything cancels out nicely, which we write here. Formally, I can then write a brief explanation for the inequality and then state that this shows what I want for the z greater than 0 case. Alright, now let's finish up the proof. Suppose z equals 0. In this case, things get simpler since the absolute value of the square root of x minus the square root of z equals the absolute value of the square root of x, which is also equal to the square root of x. Additionally, if x is greater than or equal to 0, and x is within epsilon squared of 0, then we have that 0 is less than or equal to x, which is less than or equal to epsilon squared, which implies then that the absolute value of square root of x minus square root of z is less than or equal to the square root of epsilon squared, which is just epsilon, as desired. We have now established the desired implication for when z equals 0, since in this case we can pick delta to be epsilon squared. To wrap up formally, we can then say, therefore, whether z is positive or z equals 0, we have shown the desired delta exists, from which we conclude the square root function is continuous. And we're done. To recap, I will often let an arbitrary point on my domain be given and an arbitrary positive epsilon be given. Then I will show there is some delta such that we get the implication of if x is within delta of z, then the function values are within an epsilon of each other. Because we do that with an arbitrary epsilon, the function is thus continuous at z. And because z was arbitrary in the function's domain, it then follows that the function is continuous. That's all for today. You can check out more proof examples and access online tutoring via www.typal.academy.